In this lesson, we're going to be talking about multiplying and dividing integers. We're going to be looking at multiplying integers first. When you think back to elementary school and you learned how to multiply numbers, remember, multiplication is just repeated addition. We're going to start looking at using the counters to model multiplying integers first. So looking at our first example of 2 times 3, you can see we're going to put them in two groups of 3. Both numbers are positive, so we are using our positive counters. And in each group, we have 3 positive counters. And we have 2 groups of those 3 positive counters. And when we add those 2 groups, we get a positive 6. Because 3 plus 3 equals 6. The next example, 2 times negative 3. We still have 2 groups, but within each group we have negative counters, and we have 3 negative counters in each group. So in our first group, we have 3 negative counters, and in our second group, we have 3 negative counters, for a total of 6 negative counters. In the next example, negative 2 times 3. We still have 2 groups, but each group is considered a negative group. So you have a negative on the outside. The 3 is positive, so that's why we're using 3 positive counters in each group, for a total of 6 positive counters. But because each group is a negative group, it is a negative 6. The next example, negative 2 times negative 3. Again, we have 2 groups. Each group is considered to be negative, and we have negative 3 within each group. So we have 3 negative counters in each group, which gives us a total of 6 negative counters. But then remember, each group is also negative. So that negative for the group and the negative for the 6 negative counters gives us a positive 6. Let's look at multiplying integers using the rules. When we multiply integers, if both integers are positive, so 2 positive integers, that's going to result in a positive answer. If we multiply 2 negative integers, so both of our numbers are negative, we are also going to get a positive answer. If we multiply 2 integers that are different, so you have one positive and one negative, you're going to get a negative answer. So we're going to multiply as normal, but then we're going to pay attention to what the signs are. So if they're both positive, both negative, or they're different. One's positive and one's negative. So let's look at a couple of examples. Negative 9 times negative 5. First, we know that 9 times 5, we want to just, for these, we're only going to tell if they're positive or negative. So for this one, we have 2 negative signs, which is going to result in a positive answer. And like I was going to say, working ahead, 9 times 5 is 45. So that would be a positive 45 if it wanted us to actually multiply that out. Number 2, we have a positive 2 times a negative 8. So our 2 signs are different, so that's going to result in a negative answer. And number 3, a negative 13 times a positive 4. Those 2 signs are different, so it's going to result and a negative answer. Go ahead and highlight number 4, 5, and 6, and we'll come back to those later. When multiplying, you want to consider your zero property of multiplication, and all this states is that the product of 0 and any number is 0. So if you're multiplying 0 times anything, whether it's positive or negative, your result is going to be 0. For example, we already know 3 times 0 equals 0. But then we can also say negative 3 times 0 equals 0. So no matter if that number is positive, negative, if it's a fraction, if it's a decimal, it's going to equal 0. So now let's take a look at actually multiplying these. Number 7, we're going to multiply 5 times 3, which we already know is 15. And both of those numbers are positive, so my final answer is going to be a positive 15. Number 8, we know that 10 times 2 is 20. But then paying attention to our sign, we have a positive and a negative. We have different signs. So our final answer is going to be negative, a negative 20. Number 9, we know that 4 times 8 is 32. And then looking at our signs, we have a negative number and a positive number. We have two different signs, so we're going to have a negative final answer of negative 32. Go ahead and highlight number 10, 11, 12, 13, 14, 15, and 16. And then I want to take a look at number 17 with you because we're still multiplying, but this one we're multiplying 3 numbers. So you want to multiply 2 numbers at a time. And remember, with multiplication, it doesn't matter what order we multiply in, but I'm just going to go in order of the problem. So we know that 4 times 12 is 48, and that is a negative 4 and a negative 12, so your signs are the same, so it's a positive 48. Then we take that positive 48 times negative 7. And you might need to go over to the side of your paper and multiply 48 times 7 since we're not using calculators yet. And you get 336. So 48 times 7 is 336. The 48 is positive and the 7 is negative. So that's 2 different signs. So that's a negative 336 for our final answer. We're going to go ahead and skip the exponent section for now. We talk about exponents a little bit later in the year. So we'll come back to looking at exponents with negatives later. Let's look at how this would be applied to a real-world situation. Number 22. Eric owns shares of a certain stock. If he sells off 8 shares each month for a year, find the change in the number of shares of stock he owns. So you have to have a little bit of background knowledge about stock. So if you're sharing off your shares, or selling off your shares, you're giving those away. So that is modeled by a negative 8. So every month for a year, he sells 8 shares. So he's giving those away, so negative 8. And we know that there are 12 months in a year. So negative 8 times 12. You might need to go to the side, 12 times 8, to calculate 96. And then looking at our signs, the 8 is negative, the 12 is positive. Those are 2 separate or 2 different signs, so that's a negative 96. So he sells 96 shares of stock for the whole year. And how you would want to write that is Eric sells 96 shares of stock. He didn't sell negative 96. So that word sales, that helps model the negative in our problem. Go ahead and highlight number 23 and 24, and we'll come back to those. And then let's take a look at dividing integers. So you want to remember with dividing integers, so we're still talking about dividing like we learned in elementary school. So dividing, we split into groups to help us determine how many are going to be in each group. So looking at our examples, first we have 6 divided by 2. So we know we're going to have 2 groups, and then we have to divide a total of 6 into each group. So we can see we have 3 in each group. And since we're dividing a positive 6, that's 3 positive counters in each group. The next example, negative 6 divided by 2. So again, we know we have 2 groups. And then to evenly divide those negative 6 counters, we need 3 negative counters in each group. So that is negative 3. Negative 6 divided by 2 is negative 3. So remember, with dividing and you're modeling it with counters, your answer or your solution is the number of counters in each group. The next one, 6 divided by negative 2. So that second number tells us we have 2 negative groups. So again, we're putting that negative on the outside of our parentheses, on the outside of our group, to show that that whole group is negative. But the counters on the inside are positive because that 6 in our problem is positive. So we have 3 positive counters in each group. So we have 3 positive counters, but because that group is negative, it's a negative 3. And then our last example, negative 6 divided by negative 2. So again, that negative 2 tells us that our 2 groups, the 2 tells us we have 2 groups, the negative tells us that each one of those groups is negative. And then we're dividing negative 6 into each group. So each group is going to have 3 negative counters since you're dividing negative 6. So in each group, we have 3 negative counters, but then remember, the whole group was also negative. So because the group is negative and we have negative counters in the group, our final answer is going to be a positive 3. So using the rules for dividing integers, they're just like dividing, or they're just like multiplying integers. The quotient, when you have 2 positive, so 2 positive integers, that quotient is also going to be positive. If you have 2 negative integers, so if both your numbers are negative, your quotient is going to be positive. And then if your 2 integers are different, so you have 1 positive and 1 negative, your quotient is going to be negative. So it's just like your rules for multiplying. So taking a look at a couple of examples and just determining whether they're positive or negative answers. Number 1, negative 18 divided by 3. You have a negative and a positive. So you have 2 different signs. So your final answer is going to be negative. Number 2, they've written the division a different way using the fraction bar. Negative 16 divided by 2. Again, we have 2 different signs. We have a negative and then we have a positive. So that's going to result in a negative answer. And number 3, again, using that fraction bar to model division. Negative 54 divided by negative 9. We have 2 of the same signs, a negative and a negative, which is going to result in a positive answer because both those signs are the same. Go ahead and highlight number 4, 5, and 6. And then let's take a look at actually solving these, so doing the math behind it. Number 7, so we're going to divide just like we normally divide. 8 divided by 2 is 4. But then we have a negative and a positive. So our two signs are different, so it's going to result in a negative answer. Number 8, again, dividing like normal. 21 divided by 3 is 7. And we have two signs that are the same, so it's going to be a positive 7. Number 9, we know that 72 divided by 9 is 8. And then our two signs are different. So we have a negative and we have a positive. So since our signs are different, our final answer is going to be negative. Now go ahead and highlight the rest of those problems, 10 through 21. We will come back to those. And then let's take a look at some specifically zero problems. So you have to remember with dividing that when you're doing 0 divided by a number, that's always going to be 0. Just like your multiplication rule, similar to that one. But with division, we have to remember that you can't divide by 0. So 0 can't ever be your second number or that number in your denominator. If that is the case, your answer is undefined. Because remember, we can do 0 divided by a number. We just can't ever divide by 0. Because you can't break a number into 0 groups. You're going to have some amount of group. So looking at what that would look like, number 22, 0 divided by 3, we're dividing by 3, so that's 0. Negative 12 divided by 0, divided by 0 is undefined. You don't want that second number or the denominator number to be 0. So like in 24, your denominator is 0. So you're dividing by 0, so that's also undefined. And then 25, 0 divided by 16 is 0. That numerator or your first number is 0, so your final answer is 0. So looking at kind of a real-world example, the number of employees at a company declined by 84 people in a 6-year period of time. Find the average change in the number of employees each year. So there's a couple of keywords in here that tell me this is a division problem. We want to pay attention to the words average change, but specifically this word each. That each word is a big word that helps us know that this is a division problem. So we're going to be dividing not just 84, but negative 84. And that 84 is negative because of this word declined. So it declined by 84 people. So it's negative 84 divided by 6. Because over that whole 6-year period, it was 84 people. But we want to know the change each year. So 84 divided by 6, it might need to be a problem. You come over here to the side and do a little long division. And we see that that results in 14. But since we have a negative integer in there, we need to remember our rule. A negative divided by a positive, two different signs, results in a negative answer. So negative 14 employees each year. So that negative is telling us it's going down by 14 employees each year. Go ahead and highlight number 27 and 28. That is all I have for